Alright guys, today I am excited to tell you that we are done learning and proving identities. Yay! So this last section for chapter 5 of the equations chapter, we're going to be talking about trigonometric equations, or solving for trig functions, or solving for the x, solving for the angle. Okay, now before, you used to just use arc-sin in your calculator and get an answer. However, we want more specific. We're actually looking for those special angles that we have our chart for. So that's including, pi over 2, pi over 3, all of those things. So those are the numbers we're looking for when we say solve for x. So because of that, we're not going to be using our calculator to find these answers. So we're going to solve trig equations on the interval from between 0 and 2 pi. So remember, once you figure out your solution, all you have to do is figure out the next 3 quadrants in order to get all the way up to 2 pi. All right, so in order to solve trig equations, you actually can use the identities that we learned or any other techniques we have learned to help us solve trig equations. So it's kind of a free-for-all as long as you are, following the rules correctly. Like you can't do anything that we haven't learned yet, but as long as you are doing it properly, you can use it. Okay. When you solve for a trig function, you need to isolate the variable by applying the inverse operation. So let's look at an example. Let's say we want to solve for x, okay? So we have tan x minus square root of 3 equals 0. So to isolate, we're going to add square root of 3 to both sides. And we get tan x equals the square root of 3. And you might think, okay, now all I have to do is divide by tan. That's illegal. Remember, when we go back into logarithms, that tan is an operation on x. So tan x is one entity. So we have to do the inverse of tan inverse, which on your calculator is arc-sin. So before, you could just plug in second tan square root of 3 to get your answer. But remember, we don't want that answer. We want you to use that chart, and I want you to tell me at what angle is tangent the square root of 3. Okay, and you can look and you say, oh, well, at pi over 3, tangent of pi over 3 is the square root of 3. If you notice, my solution has plus k times pi. And you're like, well, why is that? Well, if I want to know what the other quadrants answer is, I had to add pi each time. So again, here's pi over 3. Add pi and I get 4 pi over 3. Subtract pi, I get negative 2 pi over 3. And subtract another pi, get negative 5 pi over 3. So you keep doing that to you can get as many x's as possible. So you're like, well, I don't want to write an infinite amount of answers. Well, that's why we restrict the interval. We usually say between 0 and 2 pi. Okay, so that way you're not having to write out a whole bunch of answers. Okay, next example, solve 2 times cosine squared x plus 3 cosine x plus 1 equals 0. And they give us the interval between 0 and 2 pi. So when I see this, what I am seeing is a quadratic. And you're like, Miss Moss, I don't see a quadratic, I see trig. Well, if you think that cosine squared and then cosine and then plus 1, I'm seeing something like x squared plus x plus 1. I'm seeing a quadratic. And so I know we have the coefficients 2 and 3. So you can use whatever method you want. You can use the box method, however you want. But I factor that and I get 2 cosine x plus 1 times cosine x plus 1. And it works because 2 cosine x times cosine x gives me 2 cosine squared x. 2 cosine x times 1 is 2 cosine x. 1 times cosine x is cosine x. And 2 cosine x plus 1 cosine x gives me that 3 cosine x. And then 1 times 1 is 1. So 1 times 1 is 1. So again, I just factored that, right? I factored that. Now that I have it set equal to 0, there's a property that says that 2 factors multiplied together that equals 0. That means that one of those factors is equal to 0, which says that So that means that this factor, the 2 cosine x plus 1 is equal to 0, or cosine x plus 1 equals 0. So I've solved both of those, and I end up with cosine x equals negative 1/2, and I also get cosine x is equal to negative 1. So again, I set this factor equal to 0. I subtracted 1. I divided by 2. That is how I got 1/2. And then I set this factor equal to 0. I subtracted 1 from both sides, and that's how I got negative 1. So from there, remember, we want to find out what angle or x, what angle is x, so that if I say cosine of this angle, I get the answer negative 1/2. And then again, cosine of what angle gives me negative 1. So you look on your chart and you say, well, 2 pi over 3, 4 pi over 3, and pi, okay? Those are the angles between 0 and 2 pi that I get negative 1/2. Solve sine 2x equals cosine x. And again, we have the interval between 0 and 2 pi. So this is a double angle formula. So I'm going to go ahead and use that identity and say that sine of 2x is the same as saying 2 sine x cosine x equals x. I'm going to subtract cosine x from both sides. I'm going to go ahead and factor out a cosine x, because then I get 2 factors equal to 0, which tells me that cosine x is equal to 0, or 2 sine x minus 1 is equal to 0. So if I set those both equal to 0, and then I solve, either cosine x is equal to 0 or sine x is equal to 1/2. So I'm going to look at my chart. What angles, when I say cosine of that angle, do I get 0? And again, for sine, and what angle can I plug into sine that gives me 1/2? And when I do that, I get pi over 2, 3 pi over 2, pi over 6, 5 pi over 6. All of those are valid angles that when I plug into cosine x, I get 0, or when I plug into sine x, I get 1/2. All right, so this one, solve for x. 3 cosecant x minus sine x equals 2. So cosecant, remember, is the reciprocal of sine, right? So 3 cosecant x is the same as saying 3 over sine of x, because cosecant is reciprocal. So now that I have 3 over sine x minus sine x equals 2, I'm going to multiply everything, the entire equation, by sine x, eliminating my denominator. So I get 3, because sine x over sine x is 1, so 3 minus sine x squared equals 2 sine x. So I'm going to go ahead and subtract 2 sine x from both sides. And I'm going to rearrange this so that way it's in order. And I'm also going to multiply everything by negative 1 so that way I no longer have a negative in front of sine x squared. And when I do that, I have sine x squared plus 2 sine x minus 3. Again, a quadratic that I'm going to factor. It becomes sine x minus 1, sine x plus 3, right? And now we set each of those to 0, which means that sine x is equal to 1, or sine x is equal to negative 3. So looking, we notice that there's no angle that if we plug it into sine, we get negative 3. That angle does not exist. So we can go ahead and cross that out. That's not a valid problem. And so we're looking at just one, and we just get the answer pi over 2. That's the only angle that's a solution for x. All right, next example, we have secant squared x equals 3 times tan x minus 1. So now I have two trig functions. I have secant and tangent. So I'm going to use my identities so that way I can make them look similar. I know that secant squared x can be rewritten as something that has tangent. So secant squared x is the same as saying 1 plus tangent squared x. So I'm going to go ahead and rewrite that. And now you notice I have tan x, all right, which is great because now I can solve. So what we're going to do is we're going to go ahead and put everything on one side. Okay, so we get tan x squared minus 3 tan x plus 2 equals 0. Factor it, we get tan x minus 1 times tan x minus 2. And we solve for tan x, and tan x is equal to 1, or tan x is equal to 2. So looking, we get pi over 4, 5 pi over 4. I'm not sure what those decimals are, so like I said, we don't want to even deal with decimals. We're just looking for the answers that are given, the pi over 4 and the 5 pi over 4, the answers that are given right off the chart. Okay, so here's a chart that y'all have seen before, right? We have our angles on the top. We have the sine x, cosine x, and tangent x. So again, we had something like that said, you know, cosine x equals 1. Or I'm sorry, it was cosine x equals 0, right? Cosine x equals 0. And we wanted to know what x was. Well, x was pi over 2. Okay, so that's how you use your chart. And if you want to go ahead and you're going to use reference angles to get anything from pi over 2 all the way to 2 pi. So let's review how we get other angle measures using reference angles, okay? So first, let's review sines. If you're looking at sine of an angle, it's going to be positive in quadrant 1 and 2, negative in quadrant 3 and 4, okay? So in quadrant 1, it's just sine of x. But if you're trying to figure out what that x is in quadrant 2, you're going to do pi minus x, okay? If you're trying to figure out what sine of x is in the third quadrant, you're going to add pi to it. And if you're going to try to figure out what x is in the fourth quadrant, you're going to do 2 pi minus x. So that gives you your other angles other than just x, okay? Now let's look at cosine. Cosine is positive in quadrants 1 and 4, and it's negative in quadrants 2 and 3, okay? So in quadrant 1, you just have x as your angle, okay? Let's say you want to know what cosine is in the fourth quadrant. You would take 2 pi and you would subtract x. Let's say you wanted to know what cosine is in the second quadrant. You would take pi and you would subtract x from it. If you wanted to know what the x is in the third quadrant, you would just add pi to it. So again, this is just a way to get your other angles, okay? Tangent, positive in quadrant 1 and 3. It's negative in quadrant 2 and 4. So for quadrant 1, your angle is just x. In quadrant 3 is whatever your angle is plus pi, right? Whatever your angle is plus pi. In quadrant 2, it's going to be pi minus whatever your quadrant 1 angle was. For quadrant 4, you're going to take 2 pi and you're going to subtract whatever that first quadrant angle was. So that's how you get your other angle measures using reference angle x. All right, that's all I have for you today. You're going to try 5.8, 2 through 6 evens. It is due in class with your notes.